Okay, so I need you to be patient with this section. This whole chapter is a little bit tough, but you can do it. So first of all, let's think about the tangent to a curve. They kind of take it a little bit deeper. We usually talk about the tangent of the curve just being a line. It kind of butts up next to it and touches it at one point. And another way you can think of it, if you like zoom in really, really, really close, your tangent line is the best approximating straight line. Like if you would get really close and then really close and really close, the tangent line is just where it would happen to be straight if you zoomed in really, really close. Now, if we're just talking about a curve like this one here, is just going to touch at one point. A tangent line could actually cross through. This is where it's really flattening out here. And we call this tangent line a point of inflection. Okay, so probably to me, one of the more important parts of this whole thing is this bottom part. And I'm just going to kind of start over here. Oops, hang on. I'm going to cover this part up. I want you to think about if we have a point A, f of A. First of all, how do you write an equation of a line in point slope form? Y minus the y coordinate equals the slope times x minus the x coordinate. So I want you to think of a tangent line with point A, f of A, so this is just whatever that y value is. What would the gradient or the slope of the tangent line be? Remember, the slope is the derivative at that point. So let's fill in. This is my x, this is my y, this is my slope. Y minus the y coordinate equals the slope times x minus the x coordinate. And if we want to get y by itself, I'm just going to add f of A to the other side. And that's my final answer. Okay. So this ends up being a lot easier. To me, this looks really complicated. We're going to actually have values for the most part to plug in for our f prime, for our derivative, and for my x and y. So let's see what that looks like. Find the equation of the tangent line. This is something I see a lot. So you have to know two things to write an equation of a line. You need a point, and you need a slope. So if we want to find the point when x is 1, we just have to plug it in. If I plug 1 in for f, I get 1 squared, which is 1 plus 1. So when x is 1, y is 2. That's the point we're going to use. Now I need the derivative because that's what finds the slope. So the derivative of x squared plus 1 is 2x. So my slope is just plugging the x value in, which is just 2. How do you write your equation? Y minus the y variable equals the slope times x minus the x coordinate. Now you can leave it like that. If they ask you to put it into y equals, you would just need to distribute and add 2. If they do not specify the form though, this is good enough. Either way, these are equivalent equations, so either one is fine. Okay, horizontal tangent, first of all, tangent is the derivative. Horizontal slope is just a zero slope. So whenever you see a horizontal tangent, it's just asking when is the derivative equal to 0. So if we take the derivative, I'm going to say y prime because it's y, is 3x squared minus 12. When does this equal 0? Add 12, divide by 3, take the square root. Remember, you need the plus or minus to get plus or minus 2. Now, they want the equations of this. So first of all, what's my y value going to be when x is 2? That's 2 to the third minus 12 times 2 plus 2. You plug all that in, you get negative 14. So this particular point, when x is 2, y is negative 14. And how about when x is negative 2? And when you plug all that in, you get positive 18. So these are my two coordinate points when I have the derivative equals 0, horizontal tangent. If I want to find the equations, now let's think about this. What is the equation of all horizontal lines? Horizontal lines are just y equals whatever that y coordinate is. All right? So really, I just need these y coordinates, and my final answer, y equals negative 14 and y equals positive 18. Final answer. So first of all, keep in mind, our goal is, if you see anytime you see the word tangent, take the derivative. The derivative here isn't hard. Horizontal, set it equal to 0, find your x coordinates. Every step in the right direction, you're going to get points for. Then you just have to reason your way through. Okay, so this one, show that, so they're giving us our final answer, show that the equation to the tangent line of y equals, ln x, at the point where, this is the tricky part, where y equals negative 1. So then our coordinate point, I don't know what the x is, but I do know the y. So let's come back here. Let's find the x when y is negative 1. How do I get to x? I need to counteract ln. What's the inverse of ln? Is e. Now remember, e to the negative 1, that's just 1 over e. So that's the coordinate point. Now I need to take the derivative, equation of the tangent. As soon as you see the word tangent, take the derivative. What's the derivative of ln x? 1 over x. My slope, I need to plug in my x coordinate in for x. So 1 over e is e. So plug in my point and slope. Y minus my y coordinate makes that plus 1 equals my slope times x minus my x coordinate. Distribute e. E times 1 over e is just minus 1. Subtract 1 from both sides. Whenever it says show that, that needs to be your last step. Okay, this one gets a little trickier. First of all, find where the tangent means take the derivative. Y prime equals 3x squared plus 1. And I want to find what is the actual slope at the point 1, 4. What does my slope equal when x is 1? 3 times 1 plus 1. So the slope of the line itself is 4. So let's write the equation of the tangent line. Y minus my y coordinate equals the slope times x minus my x coordinate. Let's solve for y. Add 4 to both sides, so the 4's cancel. So this is the equation of the tangent line. Now, I want to know, when does this line cross this line again? Because we know this is one of the points. So I'm just going to set 4x, this equation, equal to the original equation. And then we can just use our graphing calculator. So plug in, I would say, this for your y1, this for your y2, and find where they intersect. This is going to be 1 point. And then when you look for the points of intersection, you should also find it intersects at the coordinate point -2, -8. So your graphing calculator can help you with this one. Okay, so this one can also be a little tricky, so just kind of bear with me. So we've got this equation. So let's think about y equals x squared is just your parabola, correct? So like if this is 1, 1, 2, 3, say is just somewhere over here. We're going to draw tangent lines. So if you can kind of see, like this is kind of what we're going to be looking for. The equations of the tangent from this coordinate point. So what I want to do is find a general point somewhere on this curve instead of just so if I plug in a into my equation, I get a squared. So my coordinate point is a squared. What would the derivative be? Y prime is just 2x. So then if I want to find my slope, that's when x is a, 2a. So what I'm going to do is use my slope and my point and write an equation. Y minus a equals 2a times x, my y is a squared, sorry, minus a. Now I'm going to solve for y. And, keeping in mind, this point, this particular point goes into my equation, so I can actually plug in the 0.23. Let's simplify our y though. Let's add a squared because then I can simplify this a little bit. Because add a squared to -2a squared, and I just have -1a squared. But I can use this point, plug it in for y and x, and solve for a. So my y coordinate was 3. My x is 2 times 2a is 4a. And this allows me to find each of the points for a. So I'm going to get a squared minus 4a plus 3. Because how do I solve a quadratic? I need to get one side equal to 0, moving everything over. A minus 3 times a minus 1 And so my two values, I get a is 1 and I get a is 3. So to find the equations of the tangents, I'm just going to, first of all, okay, and I'm going to stop there. Okay, sorry, I got interrupted. So remember, this is our general equation of the tangent lines. So once I solve for my a, I can just plug in 1 and 3. So I get when a is 1, 2x minus 1. And when a is 3, I get 2 times 3 is 6x minus 9.